All right, so just a reminder that these questions are kind of a listing of very common questions that you can encounter. It's not all encompassing. All right, so you want to make sure that you are using that review guide in conjunction with your notes. Excuse me. So you can be as best prepared as you can be. Let's go and do question number 1 right off the bat. Let's get our brains moving here. Of the following sets of elements, which set would be expected for the members to have very similar chemical properties? Okay, so I'm going to give you a moment just to look at these. Okay, but don't worry about answering. I want you to get the idea in your head. All right, so on the periodic table, you need to locate the following elements. Okay, chlorine, bromine, sodium, silicon, arsenic, tellurium, neon, sodium, magnesium, bromine, iodine, astatine, phosphorus, selenium, iodine. Okay, those groups of 3 elements. There is one group that we would expect that between the 3 of them, they would have very similar chemical properties. Let's look at it. That would be bromine, iodine, and astatine. So look those elements up on your periodic table. Why would we say that those elements have similar chemical properties? Well, if you look at where they're in the same group, right? They're in the same family. Okay? That's why I've mentioned before where I'll often call groups families, because all the members in a group, for the most part, will share very similar characteristics with each other. Okay? So these 3 being in the same group or same family, same vertical column, they should have similar chemical properties. Question 2. Atomic radius generally increases as we move, and this one's wanting both trends. Okay, so we're talking vertical and horizontal. So since you're using your periodic table, you should see that atomic radius generally increases as we move down a group, so from top to bottom, and right to left across a period. So top to bottom, right to left, atomic radius will generally increase. Excuse me. Question 3. And again, don't get caught up on, if you are writing questions down, that's fine, but don't get caught up because, again, I will be posting all these to classrooms sometime later today. Question 3. Now, this is going to make you recall a term here. Which isoelectronic series is correctly arranged in order of increasing radius? To jog your memory, or to kind of bring it back, it's been probably a week and a half or so since we talked about an isoelectronic series. But an isoelectronic series, excuse me, is simply a grouping of elements that have the same number of electrons. Okay? So, looking at these, first you want to identify, there are certain situations where you might have to identify if it is in fact an isoelectronic series, but this one tells you right off the bat that it is, okay? So, we're dealing with the ions of potassium, calcium, the noble gas argon, and the ion of chlorine, okay? So, all of these elements, or ions and elements, should have the same number of electrons. So we need to place them in order of smallest to largest radius. And the key to remember when doing a question like this is when you do have an isoelectronic series, size is going to be based off of the atomic number. The larger the atomic number, the smaller the radius. Therefore, the smaller the atomic number, the larger the radius. Okay? So let's look. So the correct order should be Ca2 plus is the smallest, followed by potassium, then argon, then chlorine. So if we look at the periodic table, we find calcium's right here, atomic number 20. Potassium's 19, argon's 18, and chlorine 17. So again, calcium is the smallest because it has the larger atomic number. Chlorine is the largest in terms of radius in this isoelectronic series because it has the smallest atomic number. Question 4. What is the correct order for atomic radius from largest to smallest? So this question is having you put it in a different order. You're starting with largest, then going to smallest. I can't stress enough about how you need to read the questions carefully. And I've been kind of hounding everybody, not just this class, but all the classes, hounding everybody to make sure that when you have a question that you have to place in order, make sure you verify what order the question is asking you to put them in. Okay? So we've got calcium, potassium, arsenic, germanium, krypton. Well, using your periodic table and your trends, the order should be this. Potassium, calcium, germanium, arsenic, and krypton. So take a look at those elements right there. You got krypton, germanium, arsenic, potassium, and calcium. What do we notice about all of those elements? They are in the same period. So you can use the trends of atomic radius, the horizontal trend, to help answer that question. So as you remember, the trend for atomic radius, as you go from right to left, it increases. Question 5. What is the order of first ionization energies? Again, going from largest to smallest. You have chlorine, sulfur, aluminum, silicon, argon. So again, this is a new trend. First ionization energies. So, given these 5 elements going from largest to smallest, you should have argon, chlorine, sulfur, silicon, aluminum. So again, if you look at the periodic table, they're all in the same period. Okay? So, knowing your trends, as you go left to right, your ionization energy is increasing. Question 6. Of the following elements, blank has the most negative electron affinity. Now I want you to think about this answer. I want you to think about it. Of the following elements, blank has the most negative electron affinity. As a reminder, the more negative an element has in terms of electron affinity, the larger its value is. The stronger it is, if you will. So we got sodium, lithium, fluorine, beryllium, nitrogen. Think about what you would respond with. Let's see if it matches the answer of fluorine. In fact, fluorine is possibly, I believe it is the most negative, has the most negative electron affinity. Could be wrong. There might be one, but I'm pretty sure it's fluorine. So again, using those trends. So I'm letting you have this periodic table tomorrow that you've been working on. Question 7. Now listen to this question carefully. Sodium is much more apt to exist as a cation than is chlorine. What is a cation again? But simply a positively charged ion. And an anion is a negatively charged ion. Now, think of the location and the trends of why would sodium be more apt to exist as a cation than chlorine? You know what apt means? Likely. Okay. Why would sodium be more likely to exist as a cation than chlorine? Well, the answer is this. Sodium has a much lower ionization energy than chlorine does. So it's going to be really happy and glad to get rid of its electron much easier than chlorine is going to want to get rid of any electrons. Now let's flip the question here. Let's flip it around a little bit. Why would chlorine be more apt or more likely to exist as an anion than sodium? Well, what's the opposite of ionization energy? Well, it would be electron affinity. Okay? Chlorine has a much larger electron affinity than sodium does. So it's going to be very glad to take in an electron to get its full octet noble gas configuration than sodium would. Sodium is one electron away. That's why it's like, just take it. Take my one electron, my one valence electron out of here so I can be like a noble gas. Sodium does not want to increase the number of electrons because that would just get him further and further away. So you can think about those two versions of that question utilizing different trends. Question 8. Again, I want you to think about this one. Of the following elements, blank is least metallic. Of the following elements, blank is least metallic. You've got magnesium, you've got argon, aluminum, potassium, and sodium. So using the metallic character trend, if you came up with the answer of argon, you'd be correct. Because what is argon? It is a noble gas. So we would expect a gas to have little to none in terms of metallic character. Okay, all the other ones are metallic, or so are metals, but varying degrees of metallic character. And I believe this might be the last question. Which of the following compounds would produce an acidic solution when dissolved in water? You've got calcium oxide, magnesium oxide, carbon dioxide, sodium oxide, or strontium oxide. One of these is very different from the rest. Okay? Calcium oxide, magnesium oxide, sodium oxide, and strontium oxide are all considered metal oxides. Okay? From your notes, metal oxides produce basic solutions. Carbon dioxide is the only molecular, meaning non-metal compound. So, as we saw in the notes, molecular compounds, when dissolved in water, or molecular oxides, I should say, tend to form acidic solutions. Carbon dioxide, I even had asterisks next to, because that's a very common one. Okay, it makes carbonic acid, which in carbonated beverages is what you're drinking. Okay, so that is why carbon dioxide is your best answer. So remember, molecular compounds or molecular oxides, when dissolved in water, will form acidic solutions. Metallic oxides, when dissolved in solutions, will form basic solutions. Oh, got one more. Maybe we have two more. I can't remember. What possible states could non-metals be at room temperature? Again, we got three main states of matter that we typically associate with. Yes, there's a fourth state of matter for those of you sitting at home and listening to this. Is the fourth state, the plasma, but we're talking about on the periodic table, okay? The three states of matter that a non-metal could exist at room temperature, and that would simply be solid, liquid, and gas. Bromine is a liquid. Chlorine is a gas. Sulfur is a solid. Those are all three examples of nonmetals, all three representing the three different states. Oh, we do have one more. Next question. This type of element has low ionization energies, is malleable, and is ductile. Think about that and how you would respond. If you said metal, you win the prize. You win the prize. That's from when we start talking about group trends towards the end of the chapter here, where we compared metals versus non-metals. That's where it comes from. And that's the last one. Okay. So real quick reminder, okay, for tomorrow's test, you're going to be seeing questions like that, okay, where you have to apply trends to solve the answers. Again, please also read questions very carefully that ask for order and make sure you know which order, whether it be largest to smallest or smallest to largest, okay? Secondly, or thirdly, I don't remember what number I'm on, but don't forget that your problem set is due tomorrow. Okay, the remaining problem sets, I think it's questions 49 all the way to the end. Okay. You should have had plenty of time to work on them, turn them in class, be done with it tomorrow. As you are working on your test, I will be coming around and handing, for those of you who are in class, if you are a remote student, you will not be participating in this, but we will be doing a lab Thursday and Friday. So I'm going to hand out the lab packet as you're taking the test tomorrow. And for tomorrow's homework, you will have to do the pre-lab. Okay, so you can do that after your test. It's only like 2 or 3 questions, nothing crazy. So that is all for the review. Again, I'm going to stop the recording and